Yep. Any question for this fine gentleman? Don't be shy. Don't make me ask, do you have quantum in green or pink? Yes, Simon. Please say who you are so he can identify.
So, Simon Moore, University of Cambridge. I don't really know a huge amount about quantum computing, but I guess you've touched on this already. I mean, have you got a feel for what the killer applications are going to be? I mean, you said science. Is there something in there? I mean, at one point I thought it might be protein folding or something, but much to my surprise, machine learning seems to have done quite well there. So yeah, what are the killer applications?
Thank you for the question. So yeah, this slide was sort of a catch-all for all that. Didn't have time to talk much about it. I think most problems, most optimizers we use today, they don't scale well. Like, Amazon can't optimize the path of all of their trucks every day. They take a good guess though. Even the traveling salesman problem we can break up the regions into small enough that we can handle, and then we can stitch them together. But we might be missing the global minimum by doing that. So I think anything that you can call an optimization should be something tested on quantum computers, looked at it in different ways. And I think machine learning is another class of quantum circuits that might be able to, take advantage of all the correlations that you have inside the system in order to find, do something like pattern recognition. The real problem with machine learning is that quantum computers are actually they're not big data machines or high bandwidth machines. The inputs are simple and slow, and the outputs are simple and slow. But what you get is this amazing connectivity and correlations within the system. And this is what happens when the brain recognizes a cat versus a dog. It's not the pixels that matter. The big data really doesn't matter. It's certain correlations that your brain's really good at recognizing that maybe if you shake a quantum system in the right way, we really don't know how to do this, but it sort of has all the hallmarks of something a quantum computer should do. So anything that you can put optimization on, I think there are people working on quantum versions of that. So I think the chemistry app is a really big one. I hinted at it. The reason why is it's already a quantum problem, so it sort of more naturally can be mapped to qubits. And I hope I sorry to reference you, Russ, all the time. I hope you're going to show some wonderful data on some of your chemistry stuff.
Russell, you have been quoted more than once.
I know.
Yep, there is one question. Please say who you are.
Sure. Hi, this is Jeffrey Vetter from Oak Ridge. Thanks for the great presentation. I was curious if you're aware of the quantum benchmarking initiative that DARPA's ramping up, and just what you think they hope to achieve with that benchmarking effort.
Okay, here goes. They're partnering with PsiQuantum, which is actually not really a startup. They probably have $1 billion of funding, but they're very secretive. They're using all photonic approaches, no memory. It's just photons, and also Microsoft. And I guess I already indicted Microsoft. That DARPA program, I think it's unbelievable. You heard it here first. What a waste. I mean, I just don't see either of those approaches going anywhere, but I think DARPA also wants to spy on what's going on in companies. That's okay. Companies in the US should be open to that if the price is right. And I think PsiQuantum is so secretive, and Microsoft, their topological approach, I mean, nobody really knows how it works. So I think that's the point. Having it benchmarking, a suite of different technologies may be a good thing, but so far, COMME is quite dubious.
Yes, it's coming in this way.
Yeah, just a quick follow-up on that, because I think there's kind of two QBI programs, right? There's the one I think you described, Chris, with Microsoft and PsiQuantum, but now there's proposals for more established qubit technologies, I guess, and maybe you'd feel those are less dubious, Chris, but I don't want people conflating the two, right? I think there are, this new program will have probably more established qubit technologies and try and help push scaling rapidly, right? So no,
Yeah, I understand that. I guess at a high level, independent of the company, I'm not sure that government should be picking companies here. I mean, look, we know what's going on, at least until a month ago, what's going on with AI. The US wants to clamp down and work with a big company. That's, Mark Andreessen, the famous venture capitalist and founder of Netscape, he was horrified at that with good reason. I mean, AI, there's so many things going on. I mean, look at the new Chinese startup that came out. I mean, what startups can do, I think, you have to let these things fly. And I think governments being comfortable with a big company that they may have had, legacy contracts with, that's a big mistake for AI. I think it's a huge mistake in quantum. I mean, we're way behind AI. This is AI 3.0 we're talking about, not ready yet. And for them to be picking companies, I don't know. I think it's the wrong way.
Sunita.
Hi, this is Sunita Chandrasekharan from University of Delaware. Follow up to Jeff's question on quantum. So, do you think we are even? Oh, do you want me to start? Okay, cool. Do you think we are even ready to build a quantum benchmarking suite? And if so, what do you think is the starting point?
I don't know. My feeling is that we're looking for one commercial application. By commercial application, I mean something that a third party is willing to pay for, and not just for their own research so that they get ahead of the game if quantum takes off. I mean, right now, it's like selling cars. Somebody buys a car and they get a direct use out of it. And I'm not sure what we're going to learn by having a benchmarking suite at a government lab. I mean, it'll be nice for research, I think, for science. But, companies are not into it for the science. They need to find a commercial app. So I'm not sure that's, again, I'm being very, very direct here, but I'm not sure the government should play a big role in what companies are doing.
So please join me saying thank you to Chris for this presentation, and please remind him to come back. So this is